Hey, it's Mr. Russell, and we're here to do the redox reactions by the half reaction method. Before we had the tie-in method, now we're doing the half reaction method. Tie-in method works most of the time, and it's very helpful, but we want something that works all the time. Before, a lot of the ones have been on like solids and gases, and you've commonly got an oxidation state of zero, somewhere where we had copper that was all by itself, and it was an oxidation state of zero. Now we'll be looking at ones in solution that are either acidic or basic. Uh, we won't have any neutral solutions. It'll either be acidic or basic. We're going to jump way ahead into chapter 18. We're just covering the first section. Don't panic. This is actually the beginnings of electrochemistry, and that'll be the very last unit that we cover. So we're getting a preview into the last unit. We're just doing one section, and then here's the text pages. So half reaction is we're going to take half of a reaction. We're going to look at our full equation, and then we're just going to kind of split them up and see which one was the oxidation part and which one was the reduction part. Remember, you can only always have those two together, so you'll get two half reactions. So this one would be a loss of an electron, so that would be our oxidation reaction, and this would be the gaining of an electron, of two electrons, so this would be the reduction reaction. So to do the half reaction method, we're going to have to follow 10 steps. We're going to first write the skeleton half reactions, oxidation reduction. Then we're going to balance all the elements other than hydrogen and oxygen. So any metals or something like that, we'll balance those. And then we're going to balance the oxygen by adding water. We're going to balance hydrogen by adding H+. Then we're going to balance the charge by adding an electron to the more positive side. Then we're going to make the number of electrons lost and the number of electrons gained multiplied by a factor. So hey, our factor is still here. This is the factor step still, just like you've seen before. Oh, my picture is way too big. So, and then we're going to add the half reactions together, smush them back together, the sandwich step, and then we're going to cancel out anything that is the same on both sides. Now, if the solution is acidic, you're pretty much done, but if the solution is basic, you'll have hydrogen ions in the equation. And so if it's basic, you don't want those hydrogen ions anymore. You want the hydroxide ions. So we're actually going to add hydroxides to both sides so that it will cancel out with the hydrogens and make water, and then we'll have hydroxides instead. So that's how we'll keep it basic. And then we'll check to see, and then we'll check at the end. I like this step because this is one of those reactions, one of those problems that you can do, and you can know you have the right answer before you leave. So when you take this on a test, you know you have the right answer. It's a great thing. So now let's do an example with methanol plus dichromate yields formaldehyde plus chromium. This is in acidic solution. We'll always tell you if it's acidic or basic, okay? And so I'm going to split them into half reactions. My two organic molecules are my twins, and they go together on the left side of the screen. Notice that I have two reactions here, so this is the left side of the screen. And then we have the dichromate and the chromium ion. I'm going to now balance the chromium because I had two chromiums before, and now I need to balance the chromium and put a 2 in front, kind of like you're used to. The carbons were balanced before, and right now in this step we're not worried about oxygen or hydrogen. But now in the next step we're going to balance the oxygens by adding water. I had 7 oxygens here, so I add 7 waters. I had one oxygen on the left side and 2 on the product side, so I need to add 1 water. This now threw all our hydrogens all in the mix and all messed up, so we'll have to fix that by adding hydrogen. See? And since I added 14 hydrogens in the step before, I'm going to have to add 14 hydrogens here on the reactant side of the right side of your screen. And then here I have to add 4 hydrogens. Now I'm going to take the more positive side and equal out the electrons. So what I mean by that is if I look at this one right here, this one is a -2. This total oxidation stays in -2 because of the -2 charge, and this is a +14. And then this is a +6 because I have the 3 times the 2, and then this is a 0. So this will now make a total net charge on the reactants of +12, and then a +6 over here. So we have the more positive side will now need some electrons to equal them out. Another example over here would oh man, these oxidation states. These would be 0, 0, and 0, and this would be +4. So you can see that all I needed to do is to take the more positive side and then add 4 electrons to it. So that's what I had to do there. So I'll get rid of those. And now I shouldn't have done that, sorry. And now I want these electrons on the left side and the right side to now equal each other, so I'll have to multiply by the factor. What I'm doing is I take 2 times 6 will now equal 12 electrons, and then 3 times 4 will now equal 12 electrons. That way, when I add them all together here, I will now have 12 electrons on the left side and then 12 electrons on the right side. That way they'll cancel out and I won't have any electrons in my final answer. What I've done is I've taken the reactants of the left side of the screen and added it to the reactants of the right side of the screen. I just put plus signs in the middle. I didn't do anything else. And then I took the products of the left side of the screen and the products of the right side of the screen and just put plus signs. So now I need to cancel out anything that's the same on both sides. So what I'll do is I will now I canceled out my 12 electrons because I had 12 electrons on either side. But I also had hydrogens on either side as well. So I can now take these 12 hydrogens off and subtract this number by 12. What I suggest you do is cross just the coefficient out and then write the new number on top so that it's legible. It's easy to go back and fix your mistakes when you do it that way, or rewrite it. I had 3 waters on the reactant side, so I need to subtract 3 waters off of the product side, and then I get my final answer. Then you would just need to rewrite it for your final answer. That's it for the acidic side. I'm going to post a separate video for using the basic.